So in this video, we're going to be working with arc lengths and area of a sector. Let's review that a sector is a region of a circle that is bounded by two radii and an arc of the circle. So for example, remember that the radius is the distance from the center to any point on the circumference. So the area is bounded right here, is this space right here in blue. Right? Another thing is that the central angle theta of a sector is the angle formed by the two radii. So this right here is my central angle. We know that the arc length measured in degrees is going to be the same as the central angle. But if we have any other, we're going to measure that in any other unit, say inches, feet, meters, then we use the formula arc length equals to S equals to the radius times theta. And then to find the area of that sector, we use 1/2 r squared times theta. Keep in mind here, and this is super important, is that theta is measured in radians. So if we have theta in degrees, we got to convert it to radians. Let's start with this one, right? Let's see number 1. I'm going to go over 1 and 3, and then you can do 2 and 4. First of all, my angle here is 7 pi over 6. I'm finding the arc length, so I'm finding this distance around here. So that means that S equals to R times theta. So that means that is 15 miles times 7 pi over 6. I can simplify the 6 and the 15 by 3, so I got 5 and 2, and then I'm just going to multiply. So that means that I got 35 pi over 2. For now, we're going to just keep it like that as an exact value, so 35 pi over 2, and then the unit here is going to be miles. Okay. Number 3 is given in degrees, so my first step here is to change it to convert it to radians. So I'm going to multiply times 45 pi times pi over 180. So I'm going to simplify here. So I get 1, I get 4. So that means that this equals 2 pi over 4. And now I can find my length. So it's 4 times pi over 4. This cancels out. So that means that the arc length here is pi inches. Okay, so the next one, again, I have it in radians. So I'm multiplying 14 times 5 pi over 6. I'm simplifying here by 2, so I got a 7 and a 3. So I got 7 times 5 is 35 pi over 3 kilometers. Number 4, again, first step is that I got it in degrees. So I'm going to change it to radians. So 315 times pi over 180. By simplifying here, I got 7 pi over 4. That means that I'm multiplying 7 pi over 4 times 9. So that equals to 63 pi over 4 inches, right? Because it's the unit inches. Let's see the next one. So the next one, again, here my area. My area here is 1/2 r squared times theta. So that means that is area equals to 1/2 11 squared times pi over 4. Again, theta, remember that is in radian. This is in radians, so this is 121 pi over 8. Remember, I have a 1 here. So multiplying 1 times 11 squared times pi, and then 2 times 1 times 4. And then here is yard square, right? Because I'm squaring the radius. So I got 11 yards square, so it's going to be yard square. Anytime that we have area, my unit is going to be square. See the next one. Again, I'm going to start by 135 pi over 180. So this is going to be by simplifying 3 pi over 4. So my area equals to 1/2 times 9 squared times 3 pi over 4. So that means that I got 81 times 3. So it's 243 pi over 8. And again, this one is meter squared because it's area. Okay, so number 6 It's in radians, so I'm just going to plug it in. So I have 1/2, 14 squared times 7 pi over 4. So it's 1/2 times 196, 7 pi over 4. And again, after I simplify and multiply everything, I'm going to have 343 pi over 2 meters squared. Number 8, again, I got 225 times pi over 180. That equals to 5 pi over 4. After I simplify, again, I'm going to multiply 1/2, 6 squared, 5 pi over 4. So this is 36. So I got 36 over 2. I can simplify the 36 and the 4. That's a 9. So at the end, I'm going to have 45 pi over 2. Okay. Let's see a multiplication of this. It says the outfield fence, it should say fence here. Fence is 220 feet from home plate. Find the length of the fence and the area of the field. So we know here, right? First of all, we know that in a, and if you don't know it, you're going to know it now, on a baseball diamond, this angle up down here is going to be 90 degrees. It's telling you that this distance from here to here is going to be 220 feet, right? It's the same one here, right? It's the same one here. So this is 20 feet. So as you can see, I got it like a sector of a circle. So I still can use to find this length here. I still can use the same formula. So that means that S equals 2 r times theta. Theta, again, remember that theta has to be in radians. So I'm going to simplify this. So this means that this is pi over 2. So that means that R equals 2, S equals 2, the outfield fence. So the length of the fence here, S equals 2 R, that is 220 times pi over 2. Okay, so on this case, this simplify here. So this is 110, this is 1. So it's going to be 110 pi feet. If we find that on my calculator, times pi, that's going to be 345.6 feet. The exercise is also asking me for the area of the circle. So on that case, I'm using the formula area equals 2 1/2 r squared times theta. We already know that theta is pi over 2 because we have it in radians. So area equals 2 1/2 220 squared times pi over 2. And so at the end, I get, let's find that on my calculator. So I get 220 squared pi over 4. And that's going to give you 38,013.3 feet squared. And that's it for this lesson. May the force be with you.